In our second objective of Practice Test B, this is a dilution objective. Describe how to prepare a dilute solutions from more concentrated solutions of known molarity. Our dilution equation says the molarity and volume of our first set is equal to the molarity and volume of the second set. MV equals MV. We will be given 3 of the 4 variables and pulling out with algebra the missing. So number 1 reads, how many milliliters of a 10 molar stock solution of ammonium sulfide do you need to dilute it to 150 mils of a 1.5 molar solution? Our first molarity was given as 10.0 molar. We're being asked to solve for its volume. How much of that stock solution do I need to measure out? We need to make it 1.5 molar, and we need to have 150 mils on hand. Now keep in mind, when we hit an MV equal MV dilution formula, we may keep it with milliliters. If I put a milli in, the milli comes back out. But in our first objective, the volume must be in a liter to make the molarity calculation work. But the algebra down here says as long as they're the same unit on both sides, we're good to go. So we'll hit for V1. 1.5 times the 150 divided by 10. And I'm finding a V1 value of 22.5 milliliters of stock solution. We would be measuring out 22.5 mils of the concentrated solution to dilute it down. Our second example, what is the concentration of a solution made by diluting 80 mils of a 6 molar HCl to a new total volume of 200 milliliters? So, the 80 mils of 6 molar are the variables that go together on one side of our equal. We'd like to know the new concentration when we've added enough water to make it a new volume of 200 milliliters. So, starting with 6 molar and 80 mils, we add water to create a 200 ml solution. The resulting concentration will now be smaller than the 6 molar since I've diluted it down. Let's hit. We've got 6 times 80, divide by 200, and I find the new concentration to give us to be 2.4 molar of the HCl solution. By adding water, we have indeed caused the molarity to decrease. Started at 6 molar and ended at 2.4 molar solution. In our third example, it reads to describe how you would prepare 50 mils of a 0.75 molar solution of sodium fluoride from a 1 molar stock solution. So, let's set up our MV equal MV. We need to have 50 mils of a 0.75 molar solution. All we have on hand is a more concentrated 1 molar stock solution. Let's solve for the volume of the stock we would need to measure out. Setting 50 times 0.75 divided by the 1 shows 37.5 mils of our stock solution. But notice now I'm required to describe how to prepare the solution, and that requires a sentence. Let's simply write, we would measure out 37.5 mils of the stock solution using a graduated cylinder. In order to actually cause the dilution, we need to add water. So the next part would say, let's add water to the 50 mil mark and stir. Measuring out 37.5 mils of your stock solution and adding water up to the 50 mil mark on that graduated cylinder creates the 50 mils of the 0.75 molar solution we would need to run our experiment.